Hello students, let us discuss chemical reactions of haloalkanes. In this video, we are going to discuss nucleophilic substitution reaction. As haloalkanes are one of the most reactive class of organic compounds, these can be used for the preparation of large variety of useful organic compounds. Therefore, alkyl halides are regarded as synthetic tool in the hands of chemist. Some of the reactions of alkyl halides are as number 1, nucleophilic substitution reaction. Number 2, elimination reaction. Number 3, reaction with metals. Number 4, reduction. So these are the important reactions of haloalkanes. Now let us discuss nucleophilic substitution reactions. Nucleophile is a nucleus loving group, that means which has unshared pair of electron. We can say it is electron enriched. It acts as a Lewis base. Examples of nucleophiles are negatively charged ions like hydroxyl ion, Cn negative, Ro negative, RCOO negative, and some of the neutral molecule which are electron enriched can behave like a nucleophile, that is water, ammonia, amine, etc. So these are the nucleophile which we have already discussed in 11th standard. Let us see how the nucleophilic substitution reaction takes place. When a nucleophile approaches near to a alkyl halide, at the time the CX bond in alkyl halide breaks. Because of this, the leaving group, that is X, is displaced with the bonding electrons. At the time, the nucleophile forms a bond with the alkyl group, so form RNU. Now the nucleophile is substituted in the place of X, that is a leaving group, a halogen atom. Therefore, we can say that nucleophile is substituted on the position of X. Therefore, this reaction is called as nucleophilic substitution reaction. Nucleophilic substitution reaction is due to the polarity of the CX bond. Greater the CX bond is polar, greater will be the reactivity. Here, CX is in a haloalkane, where Nu is represented as nucleophile and X is the leaving group. Halide ions are usually very good leaving groups. Better the leaving group, faster is the nucleophilic substitution reaction. When we compare the size of halogen atoms, it is a minimum size in the case of fluorine and maximum size in the case of iodine. So, among the alkyl halides, iodide ion is the best leaving group. Because of its larger size, bond length is greater in Ri. Therefore, bond can break easily. That means the I negative can be leave very easily. Therefore, iodide ion is regarded as the best leaving group. And because of this, iodoalkanes undergoes nucleophilic substitution reaction faster rate. On the other hand, fluoride ion is the poorest leaving group because of the smaller size. As we know that when the size is small, bond length will be smaller, difficult to break. Therefore, RF is least reactive. So the reactivity depends upon the breakage of CX bond. So when we compare RF, RCl, RBr, Ri, That means different halogen atoms, we can say that the bond will be easily break in the case of Ri, therefore it is most reactive, and it is quite difficult to break the CX bond in RF because of smaller size of fluorine, therefore it is the least reactive. So we can say that when the size of halogen atom increases, the bond length increases and easy to break the bond, therefore greater will be the reactivity. So let us discuss some of the nucleophilic substitution reactions. Let us discuss the reaction of alkyl halide with NaOH, aqueous NaOH, aqueous KOH, AgOH and H2O. In all these cases, the same product is obtained, that is alcohol, which is represented by ROH. Here R is the alkyl group and X is the halogen atom. So in all these cases, we are getting the same product, that is ROH, that is an alcohol. So in this, what is actually happening, the X is substituted by OH group. OH group is the nucleophile here. OH negative is the nucleophile and X is displaced, or we can say it is substituted by OH negative. This is a general equation which is given here, where R is any alkyl group. So whenever you are given an equation and it is an haloalkane or alkyl halide, and if the conditions are aqueous NaOH or aqueous KOH, AgOH or water is given at the time, you need to replace X by OH and the alkyl group will be written as it is. Let us discuss the reaction of haloalkane with ammonia and with the amines. In the first case, when haloalkane is treated with ammonia, it gives rise to 1 degree amine. In the second case, that is when haloalkane treated with 1 degree amine gives rise to 2 degree. When it is treated with 2 degree, it gives rise to 3 degree. And when it is treated with 3 degree, it gives rise to quaternary ammonium salt. So let us find how this reaction can be done. In this, X is replaced by the nucleophile and we can make easily the product when X from here, that is from haloalkane, and one H from this ammonia is removed. So what is remaining here? NH2 is remaining here and one R from here. So that is the product is RNH2. When we check the next one, in this case, one R from here and one H from here is removed as a side product. So the remaining one is one R from here, one R from here. So that is R2. We get R2 and NH because one hydrogen is removed from here. So we get R2NH. Third case, one X from haloalkane and one H from the secondary amine is removed. So rest of them will be form the product, that is one R from here, 2 R is there in the reactant side. So total 3 R and 1 N. So that is 3 degree amine. In 4 degree amine, here 1 R is there in haloalkane and 3 R are there in tertiary amine. So total 4 NH2 are there. 4 alkyl group and N plus X minus. This is called as quaternary ammonium salt. Just like ammonium chloride in which NH4Cl minus. Similarly, in the place of H, 4 hydrogen, there are 4 alkyl group. That is called as quaternary ammonium salt. In this, the fourth reaction, that is formation of quaternary ammonium salt from haloalkane, is called as Hofmann ammonolysis reaction. This is one of the name reaction. So you need to add this reaction in the list of name reaction. There are some type of nucleophile which have two nucleophilic center. That means it can bind either through A or it can also bind either through B. That means the bonding can be takes place either through A's or through the B atom because of the presence of lone pair on each. So we can say that such type of nucleophile which have two nucleophilic centers are called as ambient nucleophile. Ambient nucleophile, the good examples for ambient nucleophiles are cyanide ion and nitrite ion. Cyanide ion formula, that is Cn minus. So here the bonding can be takes place through C or either it can takes place through N. So as shown in the example here the bonding is taking place through C. You can see that R is bonded with the nucleophile through C, and in this case the R is binded with N. That means Cn can be binded with an alkyl group from two sides. That means it can either bind it through carbon or it can be binded through nitrogen. Similarly, we have one more ambient nucleophile example here, that is nitrite ion NO2 minus. It can be either binded through O or it can be binded through N. In this you can find that it is binded through N is binded with R. Here O of NO2 is binded with R. So such type of a nucleophile which have two nucleophilic centers are there. These are called as ambient nucleophiles. The examples are given here. So let us find some of the reaction of haloalkane with ambient nucleophiles. Like the reaction, when Rx react with KCN, it gives rise to RCN as a product. But if Rx react with AgCN, at the time the product is RNC, where here the Cn is a ambient nucleophile. Therefore, in the first case it is binding through C, and in the second case it is binding through N. That is, one is giving a cyanide product, the other one is giving as isocyanide product. Rx when treated with KNO2 give rise to product RONO. That is a nitrite group, that is ONO is a nitrite group, and it forms a product called as alkyl nitrites. But when it is treated with the AgNO2, it gives rise to RNO2, where NO2 is a nitro group. So it gives a product which is called as nitroalkanes. So in this reaction it is clear that there are two type of linking, that is either through the carbon atom in cyanide, and in the second case it is through N. When RCN is further reacted, when it is undergoes hydrolysis, when it undergoes partial hydrolysis, it gives rise to amide as a product. When it undergoes complete hydrolysis, it gives acid as a product, and when it undergoes reduction, it gives rise to amine. Let us see how the reactions takes place, how we can make easily the product. In the first case, that is formation of amide, here CN having triple bond, that is C triple bond N is there. So that bond will break. This bond will break and one oxygen will be added here, two hydrogen here. So we get the product R C O N H2, that is RCONH2. So we can make the product very easily. If you remember that the cleavage of bond and one O is added on the side and 2H on the other side. So we can make the amide very easily. So R is remaining as it is. Whatever the alkyl group there, it is remain as it is. Let us make for the second one. In the second reaction, CN is replaced by COOH group. So you can make very easily the product when we are getting any cyanide product RCN. So you have to replace CN by COH. So you will get the acid product, that is RCOH. Third reaction. In the third reaction is a reduction reaction in which the CN bond breaks. CN bond break. Once again, I will make it. CN bond break. 2 hydrogen on this side, 2 hydrogen on this side. So we get the product, that is RCH2NH2. So we get the product RCH2NH2. So in this reaction, what happened? The amine formation takes place due to the addition of hydrogen. It is a reduction, therefore you need to add hydrogen. Next reaction. When RX is treated with the RONA, that is sodium alka oxide. How we name this one? That is R is alkyl group and with one oxygen it is termed as alka oxide. So we can name this product, this reactant as, that is sodium alka oxide. When the RX is treated with the sodium alka oxide, it gives rise to ether as product. ROR is the ether, that is a general formula which is given here. So how this reaction is taking place? Here one X is there, this X and one Na is removed as a side product. So the remaining will make the main product, that is R and OR. As the bond break from the side, so the bonding always takes place from that side. So we get a ROR is a, that is an ether. Similarly, when RX is treated with the sodium salt of any acid, that is RCOONA, that is sodium salt of the acid. When it is treated with this, so we get a product, that is ester. Look at this, how the reaction is taking place. In this, one X from here and one Na from here, it is removed. So the remaining will be giving the product, that is RCOO. You can see the colors are given here. So you can clearly identify that RCOO is coming from the sodium salt of acid, and this R, that is blue color R, is the R which is coming from the alkyl halide. So that is actually formation of ester. So from haloalkane we can prepare ether and we can also prepare ester. From this, the first reaction, that is formation of ether, when haloalkane is treated with sodium alka oxide, then it is reaction is called as Williamson reaction. It is one of the name reaction, so you have to add this in the list of name reaction. So thus we have discussed the reaction with the haloalkane, in which there is formation of alcohol, formation of amines, formation of ether, formation of ester. So all these reactions are given here, and also the side products are given here. In the textbook, a table is given in which the reagents and the nucleophile, its nucleophile is given, and the formation of product also given, and the name of the main product is listed. So all of you go through this list of nucleophiles, their products and the name of the product, so that you can easily learn the equation with this table. So in this video, we discussed about some of the nucleophilic reactions, that the reaction which give rise to alcohol as a product, the reaction in which amines are the product, the reaction in which we are getting two product because of the ambient groups, the reaction in which we are getting ethers and ester. So these are the different nucleophilic reaction, nucleophilic substitution reaction which we have learned. In the next video, we'll be discussing on the mechanism of nucleophilic substitution reaction. Thank you everyone.